I'd like to start this by asking the question, what is an engineer? When I was a little kid, this is what I thought an engineer was. You know, the guy in the train who drives the engine. But as I got older and people told me I should be an engineer, this is what I felt like an engineer looked like. You know, the person blazing the trail, leading the way, very heroic. And well, most engineers may not look like this picture. That last part is actually true. Engineers are the innovators. We take science and apply it and make real-world solutions. Now, the problem we're studying over the summer is how do you detect small amounts of virus or protein from a sample? Now, we're looking at the first step of this sensor, which is we're taking a layer of glass or silicon and putting a small amount of gold on the surface. Now, on top of that surface of gold, we're going to add a monolayer of thiol. Now, this thiol, which has a sulfur group, preferentially bonds to the gold. And what this does is it allows the carbon chain at the end of the thiol to all point in the same direction. So you get this nice monolayer. It almost looks like a bed of nails. But what we're going to do is we have a functional group on the end of that carbon chain that's pointing up, and we're going to attach other chemicals to it that will help us detect if there's a protein or a virus. The first step in the process is cleaning the chip. And in order to clean the chip, we need to get properly attired. So here's the before. And here's the after. Now, because we'll be using hazardous chemicals, we actually have to add a second layer of protection. This is the kind of protective gear we need to have. Very difficult to hear in here. It's very hot. So now, after we're properly gowned up, it's time to clean the chip. You can see my partner Valentina taking the gold-coated chip out of the petri dish where it was stored. She's now placing it in a solution called piranha solution. Now, piranha solution sounds nasty, and it is. It's made up of 30% hydrogen peroxide and 70% concentrated sulfuric acid. The reason we need to use piranha solution is to remove any organics from the surface of the gold. Now, if any of those organics remain when we try to put down our monolayer, it won't be uniform, and we'll be left with a chip that we can't really use. So after we let it sit in the piranha solution for 10-15 seconds or so, we take it out and we rinse it with distilled water in a beaker. This should remove any of the residual piranha solution. So after the water bath, we need to remove any residual water with dry nitrogen. If we leave any water behind, it could leave drops, it could capture some organics. So we want to make sure that the chip is completely dry and placed in a dry storage area, preferably under nitrogen. Now that we have our clean chips, it's time to prepare them. A key part in any engineer's day is documentation. You need to make sure that you write down everything you do so that you can go back and look for future experiments. It's also important to capture any intellectual property you may have. So remember this, if you don't write it down, it didn't happen. The actual preparation of the chip takes many hours, so instead of going through each step, I'm just going to show you the labs where we work. This is the lab where we do all of our balancing. So we take vials that we're going to put our thiol in, we mask them before and after, we do a lot of our pipetting in the... After we have our raw materials, we bring them all into a glove box. This little glove box, which we're getting to right now, is an environment that we can control, we can keep it nitrogen filled, and protect all of our chemicals while we're manipulating them. As you can see, it looks like some futuristic orb. After we've gotten our materials out of the glove box, we do our solution chemistry. This is all done in the hood, where we use a lot of ethanol and other toxic chemicals to prepare the chip for use. Then it is left overnight. The last step is testing our chips. First test we do is done using the ellipsometer. Now, the ellipsometer is a piece of equipment that allows us to test the thickness of the monolayer that we've put onto our chip. The way the ellipsometer works is it sends a beam of light from the source beam onto our chip, and then it's reflected off onto the detector. Based on the change in polarization and inputting some constants into the computer, we can determine the thickness of our monolayer. This is a very useful piece of equipment for us. Well, the ellipsometer shows us the height of our sample. We need to make sure that we put on a pure monolayer. So now we test our chip in the FTIR. The FTIR shines infrared light onto our chip, and it tests the absorbance pattern. Now, different chemical bonds absorb different wavelengths of infrared light. So the output from the device, when compared to a reference, can tell us if our sample is in fact the thiol that we're looking for. At the end of the day, we analyze our data. If we did every step correctly and all of our results came back good, we can move on to the next layer. If not, we need to go back and look at our data and figure out what we did incorrectly. Then, at the end of the day, we get to go home and relax.